Hello, welcome to the NETCONF and YANG module of the video training series for ConfD. In this module, we're going to look at some of the background of why NETCONF exists, why YANG exists, what are the requirements they were designed to meet in this day and age of modern network management. So in context, what is NETCONF? What is YANG? NETCONF is a protocol which allows the network manager to set configuration, query configuration and operational state data, and execute administrative actions on the network device, much like SNMP did in previous generations. NETCONF is specified in the IETF RFC 6241 and provides a very modern network management protocol. In this module, we'll understand what is meant by modern network management protocol. What are the requirements that were needed for modern network management? Along with NETCONF is YANG. Where NETCONF is a protocol, YANG describes the data that's being managed by the NETCONF protocol. So the YANG data model describes configuration data that you'll configure, of course, operational state data that you need for monitoring, notifications of events that have happened in the device, an important part of monitoring as well as administrative actions like, perhaps you need to reset something or restart something for different device types and revisions. You may have revision A of a device, revision B of a device in your network. They may have different management information. In the past, it was very difficult to know exactly what device I'm talking to, exactly what its capabilities are, and exactly what its management model of data was, and which revisions of all of that. NETCONF and YANG, as we'll see, are designed to handle those sorts of needs. For most of this module, we'll talk about the background of what has happened in the standards bodies, what is the motivation, what are the requirements we need to support in a modern network management protocol. The key part of this is RFC 3535 from the IETF. RFC 3535 is an informational RFC published by IETF. It provides an overview of a workshop that was held by the IAB, Internet Architecture Board, which decides future directions of networking standards in IETF. This workshop was held in 2002. The goal of this workshop was to assess what is the state of network management, not just what are the equipment makers making, but what are the network operators using. How do we in the real world manage our networks? What is working? What is not working? For those of you familiar with the IETF's work, you know IETF is very much driven by real code and real world usage. So as one of the important things that was discovered as part of this workshop is people came to the conclusion, which everyone had known, was that SNMP had failed. For configuration, that is. SNMP was getting extensive real-world use by network operators for fault handling and monitoring of their networks. However, people were not using SNMP for configuration. They were instead continuing to script to their CLIs. And for any of you who have worked with CLI scripting for managing a device, it's a very difficult thing to implement. As devices change, you have to maintain scripts. It gets very labor intensive. It's very error prone. In fact, some operators hadn't even automated CLI scripting. They simply had network engineers typing away at consoles, working off of paper work orders, trying to configure devices. They were getting focused on configuring devices and not managing networks. So part of this workshop sponsored by IAB Cisco was an early driver for it, and Juniper quickly joined in as well, and various service providers, etc. If you look at the RFC, you'll see who all was involved in helping to determine this information. So the key part of RFC 3535, which I encourage you to read for yourself, I'll review here, are 14 operator requirements that were identified. These were for service providers and operators of networks, what they needed for managing a network. So first off was ease of use. Kind of obvious, but it's an important place to start. Ease of use for the operator. They have many different types of equipment in the network, new revisions coming out. They don't want to have to keep training their network engineers on how to work with devices in the network. Ease of use was very important for the operator. Then another thing that was identified was clearly separating configuration data from operational state data or statistics. With SNMP, there really was no clear demarc or enforcement of what is configuration data. You would get it from a device, its configuration, but it could be polluted with operational state data that really wasn't configuration. You really couldn't just read configuration from a device and then apply it to another device. So clearly separating the ideas of configuration and operational data was necessary. And remember, these are requirements that weren't just somebody dreaming. This was from the operators who had been running networks, and what real-world usage was showing was the needs and requirements for a modern configuration management protocol. Being able to separately fetch configuration data and operational data made it easier to be able to compare these between devices. If I can just get the configuration from a device and get configuration from another device with nothing polluting those views with operational state data or statistics, that's obviously going to differ between devices. I can compare them and see what is different. Perhaps I want them to be the same, perhaps I want them to be different, but being able to fetch those separately makes it, again, easier to use the network and operate it. So the other thing is the operators want to be able to manage a network. They don't want to be worrying about managing individual devices. I mean, if you think of someone like, a very large telecom operator, such as, say, AT&T, just imagine how many devices they have in their network that they're managing. They don't want to think about, I'm configuring this Cisco router, I'm configuring this Juniper router. They want to think about, I want to deploy VPN services to my customer and make it very easy to bring up and deploy this new service across my network spanning many different devices. So we need to be able to think about configuration of the network as a whole and not as configuration of individual devices. A related requirement for that is the idea of network-wide transactions. Not only do I want to transactionally change the configuration of this device, I want to be able to change the configurations of multiple devices and have them all succeed or all fail and stay at the configuration they're currently at. This is important for provisioning a new service in the network, because to do a service across the network, it's almost always going to involve multiple devices. You don't want to get into, I changed this device, I changed that device, I changed now the third device, and that fails, and I need to go back and undo my other devices. You want to be able to think about it of, I change all these devices and it all succeeds or it all fails. Very key requirement for making it easier to run a network. Also, let's take advantage of devices getting smarter. We've gotten a lot more compute power and resources available now in embedded systems and network elements than we used to have. Oftentimes, getting a device from A to B in its configuration involved needing to know at the management station, grouping and ordering. What can I change together? What has to be changed separately? What order do I have to do all of this in? A lot of intelligence had to be built into the central management systems of the network and puzzled out from the devices being used. It wasn't clearly stated for the devices what they have, how you do that. Oftentimes you had to puzzle it out. Instead, let's have these smarter devices that know their own constraints figure it out for themselves. I just want to be able to transactionally tell them I want to go to here and let them worry about figuring out their own internal grouping and ordering issues that shouldn't be exposed to that central management station. Also, I want to be able to easily back up and restore configurations of my devices. Have a standard for being able to pull a config from my device or push a config to a device was identified also as a requirement from the operators to easily operate their networks. Then also things such as validation and ease of use with existing tools. So making sure not only is my configuration valid at the individual network device level, but is that my network configuration valid across multiple devices? So being able to easily validate those configurations, we'll see with NETCONF and YANG, those sorts of things were built in where we can easily send a config to a device, ask it to validate the configuration before we take it live on the device. We don't have to do all the validation centrally if we don't wish to. Also, there was a desire identified in the requirements in this RFC to easily be able to work with the configurations that are fetched. Being able to use standard text-oriented processing tools such as diff, or being able to manage things using revision control protocols. In other words, a requirement that I'm not working with a blob of opaque binary data that's very hard to inspect, manipulate, and compare. I want to be able to, from my modern network management protocol, be able to fetch my configs, send them through standard command line tool chains to process it as text. Then a desire for standardized data models. And oftentimes our network-wide configurations are stored in a central database. We want to be able to easily map that to devices and have devices support standardized data models of information and not have different proprietary models of data from different vendors in our network. A common standardized data model that all equipment supports in my network that can describe its individual capabilities, as well as a desire for not just a standardized modeling language they support, but also standard models that they all implement as well. Then also a requirement that was identified as part of this RFC was a desire for support of multiple configuration sets within devices, so that a device could perhaps hold multiple configurations, and then you could select which one could be used. The primary driver for this is delayed orchestrated activation, meaning being able to send maybe a candidate configuration to a device that say, hold on to this configuration, we'll be using it perhaps in the future, but don't take it live yet. And being able to perhaps distribute that out to a bunch of devices and then quickly tell them all, use this now for the configuration. That very much helps orchestrating that activation of a network-wide transaction for service deployment. Finally, things such as role-based access control were important, not just user-level access control, but role-based. Is this an administrator of this box? Is this an operator? Is this a field tech? Being able to find roles and do access control based on the roles was identified as a requirement. Being able to do things such as consistency checks of these access control lists across multiple devices. For those of you who have been involved in network operations, access control lists is one of the big areas that gets managed a lot in devices. Being able to easily, consistently check your access control lists across multiple devices really makes it easier to operate your network. Looking at what had been being used at the time, S&MP access control was very much oriented to the data. If you look at the various security mechanisms of S&MP, it's oriented to the data, whereas when you're using CLI, the access control was more oriented towards what commands someone could use or what tasks they can run. So really, it's desirable to have both data-oriented and task-oriented access control for a modern network management protocol. So that's kind of a summary of the key requirements that were identified in RFC 3535. And again, these requirements were used as the basis for designing what became the NETCONF protocol that initially went to RFC in December of 2006, and then was rapidly followed by an RFC standardizing the YANG data modeling language. Now, what is the implications of the requirements that are outlined in this RFC? Well, the legacy situation that was happening that we see in this slide, where the network devices lacked atomicity, they had ordering issues, so they didn't really support transactions. We couldn't do configuration change transactions at the device. We had to know a lot more about the device for what items I could group in one set of settings or what order I needed to set things in precisely down to the lowest level of detail. So this forced information leakage to go from the network device up to the centralized management system. We had to have EMSs, consolidate those into an NMS, finally pull it together into my OSS before I could finally start running my network. But this information leakage that forced intimate knowledge of details of the internals of a network device to go into my management stack led to significant cost and complexity issues that had to happen at the central management layer as a result of how devices were implementing network management and doing this information leakage. However, from these requirements of RFC 3535, many of them, as you study the RFC, you'll see have to do with transactions, either having devices support transactions or being able to do network-wide transactions across multiple devices. A device that supports transactions doesn't have that information leakage. It isn't pushing constraints up to your central management systems. You're able to describe the data in a standardized data model and support a transaction. The centralized management system doesn't have to know the order to do things. It doesn't have to know, precise little details. It can tell you, here's the new configuration set, make it happen. Then the device will figuring out those ordering issues or any of that. The devices are, being leveraged, but it's reducing cost and complexity at the centralized management system. So what does this mean for cost of running a network? Well, when running your network, you have two primary expenditures. You have CapEx and OpEx. Your capital expenditures and your operational expenditures. CapEx comes from simply buying the equipment to use in your network. OpEx comes from running your network. Over the years, your CapEx can decrease as equipment becomes less expensive. It gets more maybe commodity hardware focused, as we're seeing, for example, in the NFV world. But your OpEx doesn't really, decrease. If you look at your total cost of ownership over 5 years for a network element, OpEx is typically 80% of your expenditure of your sum of OpEx and CapEx. And if you look at breakdowns of OpEx per task, on this right-hand box, you can see that configuration and activation OpEx cost is typically 45% of your OpEx is configuration activation tasks. By reducing the cost of OpEx has significant impact for operators of networks. So, you may be able to sell the least expensive device they could buy, but if it isn't, easy for them to manage, if it's going to be increasing their OpEx to work with, it's going to be very difficult. So supporting modern management that makes your device very easy to manage inside the network and integrate into an existing network is extremely important to the success of your network device. So, in summary, this RFC 3535 gave us real-world requirements. It was what is happening in network management, what needs to improve, and these were used as design inputs for the NETCONF protocol. NETCONF is the next generation network management protocol. YANG goes hand in hand with NETCONF, where NETCONF is the protocol. YANG describes the data that's being managed. Today, we are seeing many network operators, and it's only increasing, requiring NETCONF and YANG. There are many major service providers now telling their vendors of network equipment that if you want to have your network in my equipment, you must support NETCONF. You must provide YANG models for your equipment, because use of NETCONF and YANG makes it easier and more cost effective to manage our network. So I'd like to thank you for sitting through this module about why NETCONF and YANG, and hopefully you'll join us for other modules in this training series.